All right, with this one, we are trying to find the maxes and mins within 0 and 7 pi fourths. All right, so 7 pi fourths is really close to 2 pi, so we're going from 0 to almost 2 pi, but not quite 2 pi. So what we need to do is we need to find the derivative of this right here. And the derivative is going to be the derivative of the outside, which is cosine of x plus pi fourths multiplied by the derivative of the inside, but the derivative of x is 1, and then plus pi fourths, the derivative of pi fourths is 0 because it's a constant. So it's going to be times 1, but I'm not going to put it because we don't need to. Now, there are 3 places where a max or a min could happen. The first place is where the derivative is 0. So we're going to set this equal to 0. Cosine of x plus pi fourths. And so what we're going to do is we're going to solve for this. And so I'm going to do the inverse cosine of both sides. So cosine of 0 equals x plus pi fourths. And the inverse cosine pretty much says, okay, where is the cosine of theta going to be 0? So where is the cosine going to be 0? Well, the cosine is going to be 0 here at pi halves. So the cosine, inverse cosine of 0 is pi halves. So we're going to say this is pi halves. And this is going to equal x plus pi over 4. Now, you also need to remember that we're going all the way to here. So in other words, I need to see if there's anywhere else where the cosine is 0. So here's 0, and then here, right here, it's 0 as well. So we have to deal with 3 pi halves. So the inverse cosine of 0 is also 3 pi halves. So there are 2 places where that's going to happen. Now, I'm going to subtract pi fourths to both sides. So you end up getting x equals, now pi halves is going to be 2 pi fourths. And we're going to subtract pi fourths. So 2 pi fourths minus 1 pi fourth is actually just going to be pi fourths. So one of the places is going to be x equals pi fourths. And I'm going to call this a because a is going to be anywhere where the derivative is going to be 0. Now, this next one, I'm going to subtract pi fourths to both sides, which gives me 6 pi fourths minus pi fourths. And that's going to be 5 pi fourths. So I'm going to put 5 pi fourths in here too. All right, so I got those. That is where my derivative is 0. Most people forget the second one. So I'm going to get rid of all this. The next part is where the derivative is undefined, but it's going to be defined everywhere because it's cosine, so that's not going to have anything. And then the last place I need to check is my bounds. So I need to check x equals 0 and 7 pi fourths. Now that we have our points of interest that the max or min might happen, I need to make a number line. And I need to see if there actually is a max or a min at any of those points. And remember, the place where the max or mins happen is going to be where the derivative goes from positive to negative or negative to positive. If it doesn't do that, then you're not going to have something that goes from positive slope to a negative slope. You're not going to have a max. So for example, if you have something that goes from positive to 0 and then positive, you could get an inflection point. You won't get a max or a min. So we got to check a couple places. We got to check 0. We got to check pi fourths. We got to check 5 pi fourths. And we got to check 7 pi fourths. Now, we got to check somewhere in between, and what we're doing is we're checking points within the derivative. If you actually plug this in your calculator and find a decimal approximation to pi fourths, you'll find that it's 0.78. 5-point force is going to be about 3.92-ish, and this is going to be 5.5. So I'm going to plug stuff into my derivative and see what the sign is going to be. And I've already done that. So I decided to pick 0.5. So 0.5 is somewhere between 0 and pi force. I plug that into my derivative and it becomes positive. Then I plug somewhere in between here, which I decided to choose 2, and I end up getting negative. Right here I end up getting something positive. So it's going to be positive, negative, positive. Now remember, I'm plugging this into the derivative, not the function, so I know what the slope is going to be in between. So since this goes from positive to negative, I know I'm going to have either a max or a min here, and I know I'm going to have a max or a min here. And then because these are endpoints, a local max or a local min is going to happen. So let's plug them into my functions. So f of 0. And remember, we're plugging it into the function now because I want to see how high it goes on that function. So f of 0 is going to be the sine of pi force. And we know that the sine of pi force is the square root of 2 over 2. If you don't remember how to get that, it's going to be on my unit circle. Pi force, the sine is going to be square root of 2 over 2. Okay, we're going to plug in our next point, which is going to be pi force, into my function. And we get pi force plus pi force, which is pi halves, and the sine of pi halves is 1. You either have that memorized or you can look on the unit circle. Pi halves, the sine is going to be 1, so the sine of pi halves is 1. And then we have the function at 5 pi force, and that's going to be 5 pi force plus pi fourths, so that's going to be the sine of 6 pi fourths, which ends up being the sine of 3 pi halves. And we know that's going to be negative 1 using our unit circle. And then we have f of 7 pi force. And f of 7 pi force is going to be the sine of 7 pi force plus 1 pi force, which is 8 pi fourths, which 8 pi fourths is going to be 2 pi, and the sine of 2 pi is going to be 0. All right, now we got all our values. Now we got to talk about my max and min. Well, my max is going to happen here because that is the highest out of all 4 of these points. So we are going to have a max of 1 at x equals pi force. And then we are going to have a minimum here. So we're going to have a minimum of negative 1 at x equals 5 pi force. Now, we can also find local mins and local maxes. And so this will be my absolute max, and this will be my absolute min. So in order to find a local max or a local min, we got to know what the derivative is doing. So if you see here, it's going to be positive. So my slope is here at 0 is going to be positive. And then it's going to go negative, and it's going to go down to negative 1, and then it's going to be positive. Now, right here, this is going to be higher than this point right here. But within this local area, it is actually a min within that local area. And with this local area, this is actually a max. So if my derivative starts off positive, I know I'm going to have a min on a local min on my endpoint. So I'm going to have a local min of the square root of 2 over 2 at x equals 0. And then I'm going to have a local max because here on the end it's going to be this way, and then the endpoint's going to be on the right-hand side, which means now it's going to be a max. A local max of 0 at x equals 7 pi force. All right, now we're going to look at the graph and see what's going on and just make sure we did it right. So we are looking at the graph from 0 to 7 pi force. We know that's going to be about 5.5, which is going to be right there. So if you look, we're going to have an absolute max here, an absolute min here, and then right here we're going to have a local min, and right here we're going to have a local max. So right here is going to be about 7.8, which is exactly what we said. We're going to have a min here at about 3.9 or close to 4, which is going to be 5 pi force, and it's going to be -1. That's what we got. And then we're going to have a local min at 0 of square root of 2 over 2, which is about right there. And then we're going to have a local max here at 7 pi force, and we said it was going to be 0. So it looks like we did it right.